Today what we're going to do is we're going to take a look at a different form of the parabola. Now, the first form that we saw, y equals ax squared plus bx plus c, is called the standard form because it's the first one that we ever really saw. So take a moment and copy that down. We call that the standard form. Now, the a that you find in y equals ax squared plus bx plus c is the same a that you would also find in this equation. We call the vertex form. And you'll understand why it's called vertex form as we go into our work today. So what I want you to do is I want you to make sure that you're going to set up Desmos on your computer or your tablet or your phone and try to set the table of your Desmos, what you see, not your table, the actual graph, to have these specific values, -10 and 10 for the x-axis with a step of 1, and then -13 and +13 for its y values as well. So we're going to kind of have almost the same setup for our graph. Yours might end up looking a little fatter than mine, but that might be due to the resolution of my screen. So here's what I want you to do. What I want you to do is I want you to use Desmos to graph each of these parabolas. Every one of these parabolas we're going to graph, and we're going to identify all these things here. And I'm going to talk to you quickly about steps for the first graph, and then I will show you how we get the new steps for the next graphs. So peel away, go to Desmos, and then identify type in y equals x squared, and then tell me the direction of the opening, the axis of symmetry, its max or min, tell me if it's a maximum or a minimum value for the y value, and tell me what the vertex is, and then we'll figure out what the steps are. So pause the video, go do that, and we'll talk real quick. So here we go. We punched in that graph in Desmos, and this is our equation y equals x squared. So now that we have y is equal to x squared, what we have to do is we're going to go and do some analysis on this. So this is our base image for any parabola, right? And then y equals -x squared is the base image for any parabola that's opening down. Now, that was based on last day's work. So here is my thing. We know that this point here at the bottom of my vertex is the point 0, 0. Okay, that's good. We get that, right? Now, some of the things that we used to do a while back when we were studying, say, the equation of a line, is we would use a line and we would use some sort of pattern to always move to another point on the line. Okay? And we use the run and the rise, which we got from our slope in y equals mx plus b, to find the next point on the line once we found one point. Now, the key dividing feature for any parabola is its vertex. Without the vertex, the parabola cannot be drawn. Okay? So the reason why we spent so much time working with vertices was because we always had to be able to find them and identify them on a graph. Okay? And that's what we always did. And that's why we always did that, and we also identified this other thing. Now, the second most important line in our parabola is the axis of symmetry. Because if I find a point on the right side of this parabola, I can mirror it to the other side of the parabola. Now, let's go and look at some key points to the right of the vertex. I always use the right side of the vertex. If I look at this base parabola, this point here is 1, 1. This point here is 2, 4. And this point here is 9. Nope. Is 3, 9. Now, remember with our original lines, we would always go over one and up one, over one, stuff like that to find the points on the straight line. Now, the thing is, if we go over one here on our parabola, and if we go over one on a parabola and then we go up one, and then we go over one on parabola, and then we get to this next key point, you'll notice that there's only 3 spaces here to get to that next point up on our graph. And then to get from, say, this point here to 4 to this point is 1, 2, 3, 4. Oh, 5. So we're always moving over 1, but when we're moving up on the graph, we have to go in steps of 1, 3, and 5. What do you think the next number would be? I think the next number would actually be 7. So these are the basics for our graph. Now, we know that this graph is a positive parabola, right? Another way to say this is that this graph is opening up. Now, when we talk about whether something is its maximum or minimum, we're always referring to the max or the min always refers to the y value of our parabola. If I look at this parabola, the lowest y value is 0. Would you look at that? The lowest y value is 0. So that means all the numbers past 0, all the numbers that go up are on the parabola, but there is nothing below y equals 0. So we would say that this is a minimum of y equals 0. So let's go and take all that information and put it into our graph. So the direction of the opening of a parabola, we're going to say it's up. Its axis of symmetry, based on what we saw, is x equals 0. Our max, is this a max or a min? We say this is a min because it's opening up, man. It opens up. Think of it this way. It's opening up now, right? So because it's opening up, our y value is a minimum. And its y value, its lowest y value, is 0. Now its vertex is 0, 0. And the steps that we found for it to move up the y's on the parabola are 1, 3, and 5, and it just goes on forever. Okay? Now let's do the same. You'll find that when we go and do the next graph, which looks exactly like y equals x squared, but it opens down, has exactly the same thing, except it opens down. The axis of symmetry is x equals 0. And is this a maximum or a minimum? It's the opposite. So this is a max. And if you think about it, this parabola does this. And because it does that, because it opens down, we can say it's a maximum. And this one, because it opens up, still using the same concept that we studied before, it's a minimum. And so this is 0, 0. When we go and do the differences, guess what the steps are for a parabola opening down? It's not 1, 3, 5. It's actually -1, -3, and -5. Okay? So now, let's go take a look at y equals x cubed. Whoops, sorry. I meant y equals 3x squared. So let's take a look at that. So when you graph this, nothing's really changed except for, well, nothing actually has changed. The graph still opens up. Its axis of symmetry is 0. The vertex is still 0, 0. But wait a second. Those key points that we had before, we used to be at 1, 1 down here. And now our point, our key point that we have on our graph, if you move your finger up here, is 1, 3. Oh my goodness. It's going to be 1, 3. So let's go and take a look at that and make sure we get all that information. All right, so Remember, for y equals x squared, our steps were 1, 3, and 5. Okay? And those were the steps to move up. So if I took a look at this and I graphed it, it would look a little different compared to this graph. So this was our new graph. Our original graph would have been over 1, up 1, right here, right there, and then over 2, up 4 if I compared it to this graph. And I'll just mirror it on the other side here. So when you graph it, the old graph would kind of look like this. It would be flatter than our y equals 3x squared graph. Now, I know that this isn't exactly to scale, but what's happened is our graph has literally shrunk itself. Not shrunk itself, stretched itself. So when you look at the graph, if I basically take the graph and make it squares, our original graph would have been like this. So the y equals x squared graph would look something like this. Okay. And something like this. I'm sorry about my bad graphing. It would look something like this. And our red graph here would be y is equal to 3x squared. So if I looked at this graph, before we had a point at 1, 1, and now we have a point at here. And if we go over 1 and we go up a certain distance, there's going to be a point where they cross again. So if I go over 1 and then go up a certain number, eventually our graph will cross right here. And this point above the axis is actually 212. And now let's go and take a look at those steps that we were talking about before. So I'm going to use a black pen here. So if I go over 1 and I count up 1, 2, 3, oh, there's my first point. If I count over 1 again, in order to get to that 12th position, 12th height, this needs to be 9. So for y is equal to 3x squared, our steps are now 3 and 12. No, is it 3 and 12? No, it's 3 and 9. The step that we were looking at is 3 and 9 because our final answer was 12. So it's 3 and then 9. And so it looks like 3 went to 9, 1 went to 3, 3 went to 9. So what do you think the 5 is going to turn into? The 5 is going to turn into 15. And all we've actually done in order to move from y equals x squared to 3x squared is we've times our original steps by 3. So 5 times 3 is 15, 3 times 5 is 9, 1 times 3 is 3. So let's go back to our graph. We have all the same, we have almost everything the same except for our parabola. Our new steps on our new graphs is 3, 9, and 15. So this is what we should have for our graph. Y equals 3x squared. It opens up. Its axis of symmetry is still x equals 0 because there's nothing that changes it. And then also, is this a maximum and min? It's opening up because it's like y equals x squared and its a value is bigger than 0. Because a is bigger than 0, this opens up. So if a is opening up, that means this is going to be a min, y is a min, and that means y is equal to 0. Now, in order to get our vertex, we have to use, here is the best part, we can use this and this to find it, because both of those go through the vertex, and the vertex goes through the axis of symmetry. So 0, 0 is our vertex, and our steps are 3, 9, and 5 times 3 is 15. And we can use those steps to go and create the points for our graph. Now let's do the same. Let's see what we get for this next half of equations. So what I want you to do is I want you to work through this, and I will put the solutions up for you. You should be able to figure out the steps for each of these graphs from the vertex, just like I showed you on the graph. So you copy it and you go through it, and then you'll find the steps. And I'll pause this and I'll write the answers out for each line. So based on this work for y equals x squared minus 1, this graph is identical to y equals x squared, except it's shifted right. So if you think about it, it still opens up. Now, if this graph, y equals x squared, has moved to the right 1, the axis of symmetry has to move to the right. I'm guessing. Let's take a look. I'm going to write x equals 1 here. And the value, the maximum or minimum value, we have to figure out, is it still opening up? So it's still a minimum. Now, does the y value change if all we've done is moved our graph to the right? No, it hasn't, and y is 0. So let's go and quickly take a look at our graph. So, just like we said, when we moved our graph to the right, we moved it 1, and its axis of symmetry is still 0. Sorry, its axis of symmetry is now 1. So now our vertex, when we look at our graph, is now right here. It's now 1, 0. So we've moved all the points over. So it's only the x values that's moved. So our vertex is now, instead of 0, 0, which is right here, it's now turned into 1. And so now, let me ask you, what do you think the steps are for this graph? If I look at this graph of y equals x squared compared to y equals x minus 1 all squared, these two graphs are congruent. They don't change. The only thing that's changed is where the graph is being drawn. So they're what we call congruent, but they've only shifted in position. So if you think about measuring our points from the vertex of the second graph, the steps that we have are exactly the same as before. So we have 1, 3, and 5 for our steps. Now let's take a look at y equals negative x squared plus 3. I can tell you right away that this graph is going to open down, because we knew that negative x squared opened down. And based on the work that we did last day, this basically shifted our graph down 3. So this part means move our graph down 3. So let us fill out the rest of this graph. So part of the problem asks us to tell us what the axis of symmetry is. The axis of symmetry, if it's only moved down, that means our x value is our axis of symmetry is still going to be x equals 0. So let's and graph it in Desmos. So our graph has opened down, but our graph is opening down for y equals negative x squared, but the plus 3 has moved all of the points up. So when I go and move this axis of symmetry back, the axis of symmetry stays the same. The vertex originally was 0, 0, and the new vertex is 0. So the new vertex is 0, 3. Now, if I looked at that graph, you knew that it was opening down. So this time we have a maximum for y. And in that case, y for our new graph is 3. Now, the steps for this one are still -1, -3, and -5. Now, if you want to think about it, our original graph, when it was opening up, was 1, 3, and 5. Now, the value that is sitting in front of the x squared term is +1. The value in front of this graph here is -1. The value in front of this graph here is +1. So that's why y equals x squared and y equals x minus 1 squared have the same steps because the a values are the same. Now, if I look at the base reflection of y equals -x squared, we've got this, -x squared. And because it's actually -1, and if I could just draw it, -1, the value would be 1 times -1, which gives us -1. 3 times -1 gives us -1. And 5 times -1 gives us -5. All right, now let's finish these off here. So if I look at this next graph, I would tell you right away that this graph is opening down because of this thing here. The minus sitting in front of the 2. Anytime we have a minus, our graphs open down. Now let's go take a look on our decimal. So when we take a look at our new graph here, right? Our original vertex for -x squared was 0, 0. And now our new graph for y equals -2x plus 1 squared minus 3, it looks like the maximum is -3 because if you think about it, all of the y values exist below -3. Now, if I'm looking at oh wow, wait a second, there's some pattern coming up here. It looks like the y value is what we see in our vertex form. So let's go through that and take a look here. So let's go and fill out what we know so far. The graph opens down, yes. The vertex of our parabola was -1, 3. Or was it -3? -1, -3. Now, the steps of this parabola, I will tell you, are negative. It starts with -2. And if you think about it, what is 3 times -2? -6. What is 5 times -2? Gives us -10. And these are the steps that are based on it. So when we calculate the steps, we're always taking 1, 3, and 5 and multiplying by the number that's sitting in front of the bracket, the thing that's being squared. Now, let's talk about the axis of symmetry. The axis of symmetry is x equals -1. And that comes from my vertex. And that comes from the opposite number that shows up inside this bracket. So remember, in this case, our vertex is the opposite of what you would see inside our parabola here. So I got minus 1. Okay? So the x value is opposite of what you see inside of this bracket. And whatever's on the outside for this last bit is what our y value is. So we got y is equal to -3. Now, based on that, this is a parabola that's opening down. So so you got to ask yourself, is it a max or a min? I would say it is a max. Any parabola that opens down is a max. Any parabola that opens up is a minimum. So let's move on. Based on what you know right now, do you think you could fill this last part out? I'm pausing it, and then we're going to try filling this out with a pencil, seeing if you can guess whether it opens up and what its axis of symmetry is or what its vertex is. Maybe you can go and figure out the vertex, and then we can do the rest. Pause the video and just tell me whether it's opening down and tell me what the vertex is based on that form you see. Well, it is opening up, and its vertex is 1.55. So remember, whatever number is inside this bracket, it's the opposite for the x here. Okay? And whatever's on the outside is just copied into our vertex for y. So, based on that, the x value of my vertex gives me the axis of symmetry because the axis goes through our graph. So this is 1.5. And last part, y is equal to whatever our vertex is, which happens to be 5. Now, the steps. Remember, the original steps of the upside of the parabola opening up were 1, 3, and 5, right? Now, see this 0.5? This is how you know. This is what you do. Take the 0.5 and multiply by everything in here. So times it by 0.5, and that's what your steps are for the new graph. So the new graph is 0.5, 1.5, and 2.5. So we would go over 1, up 0.5, over 1, up 1.5, over 1, up 2.5. So now what I'd like you to do is I'd like you to copy down the information for this graph here, this last graph, which describes everything. So the first concept I want you to realize is if the a value that we have here is positive, it's a positive parabola and it opens up. If it's negative, it's a negative parabola, so it frowns, it opens down. Now, as for the vertex, it's H and K. And basically, it's opposite of what you see inside here. We say the opposite of the sign. So I call it opposite world for my x values. And notice it's only for the x values. The k value is always read as it is. So here it is. So for this one, you would say y is equal to k because it's our max. Our maximum or minimum is y equals k. And our x value is, because it's negative h inside this bracket, we just say it's h. Whoops, and we're done. And the steps for our parabola are a, 3a, and 5a, and 7a, and stuff like that. And that's it. So let's go over what we know. Based on the graph, the minimum looks like this, right? Whoops, wrong thing. A minimum graph for any parabola looks like this, doesn't it? And that's when our A value is bigger than 0. And that's our minimum. Okay? Now, the maximum occurs when our graph looks like this. I always tend to draw it in my head. And then I say, well, our A value is negative. It's a negative graph. It's sad. Now let's talk about the direction of opening. The direction of opening is up if A is greater than 0. And it's down if A is less than 0. Quick steps for graphing from the vertex. So we find the vertex. We'll call it V, and it's H and K. So remember, it's opposite of what you see. Remember, I call it opposite world. Whatever sign is on the number inside the bracket is opposite for our x value in our vertex. So basically, from the HK, we use the steps A, 3A, and 5A, i.e., take 1, 3, and 5 and multiply whatever the A value is in our graph to graph it. So here are some examples. If you understand what's going on right now, what I would love for you to do is I would love for you to go and do the problems that are on 3.3a right now. If not, stop the video and then go take a look at translating English to equations and equations back to English.